Section 4.2 talks about negative exponents in scientific notation. So the definition of a negative exponent is given to us, right here. And if it's a little hard to see, I'll write it again. It just says x to the power negative n is the same thing as 1 over x to the power positive n. So first off, I want to think of this number here as a fraction. So I'll think about it over 1. In essence, what we're saying is if we have a negative exponent and it's on the top part of my fraction, we can make that exponent positive by simply flipping the fraction, and the negative exponent, when it comes down to the bottom, now becomes positive, okay? So if you look at the directions for this first problem, it says simplify, express your answer with positive exponents, assume all variables are not 0, okay? So again, the first thing I'm going to do is I'm going to think of this here as a fraction by being over 1. And the first thing I notice is that my exponent is negative and it's on the top part of a fraction. So to make it positive, I'm simply going to flip it and we get 1 over x to the 4th. Okay? I'll do the same thing for the next one. I'll think of this as y to the power negative 5 over 1. I'm going to flip it and it just becomes 1 to the power positive 5. Okay? Let's take a look at the next part. So we have properties of negative exponents. Okay, so let's look at the first one here. Notice what it says. If my exponent is negative, but it's on the bottom, think of this as a fraction as well, guys. Think about, we're going to flip it, and if that negative exponent is on the bottom, now it's moving to the top. And let me see, let me get an eraser because I kind of covered up that part. There we go. And if you notice this one here, look, both exponents are negative. So this one that was negative came down to the bottom. Now it's positive. This one on the bottom that was negative came to the top. And now it's positive. So again, we're flipping the fraction. We're taking the reciprocal. Okay. So let's go ahead and do that with this one here. My negative exponent is on the bottom. To make it positive, I move it to the top. But remember, if we have something over 1, we can just write it as y to the 8th, right? Okay. I'll do the same thing here. Anything that has a negative exponent, I'm going to move it. Okay, so that z to the negative 5 is on the bottom. It's going to go to the top, positive 5. This x to the negative 6 and y to the negative 2, they're on the top. Let's move them to the bottom, and they also become positive. Right? Okay. Taking a look at the next problem here. We have 2x to the negative 3, all raised to the power negative 3. So if y'all remember, when we have a power raised to a power, we say we multiply the exponents. Okay, so let's multiply our exponents. Well, negative 3 times another negative 3 is a positive 9. In case we can't see it, remember the power, the power on that 2 really is the number 1. So when I multiply that times negative 3, that would give me 2 to the power negative 3. Okay, so again, I'm going to think of this as a fraction by being over 1. And I'm going to move only those things that have negative exponents. Well, notice this one does not have a negative exponent anymore, so it's going to stay where it is. This guy is going to move down to the bottom. That becomes a 2 to the 3rd. Okay. Guys, remember what 2 to the 3rd means. It means 2 times 2 times 2, which is 8. So we end up with x to the 9th over 8. Okay. Let's go to the next page. All right, let's do the same thing here. I want you to think about the power on that 5 really is a 1. And it's already positive, so I'm not going to move that one. I'm only moving those things that have negative exponents. So the y to the negative 7 comes to the bottom, gives me a positive 7. Okay. Let's take a look here. Let's do the same thing for this one. Let me move it over here where I have some room. Okay, so the z to the 3rd is going to stay where it is because it's already positive. But the x to the 5 will come to the bottom, and so will the y to the 2. Okay. Alrighty. Looking at the next problem we have here. So guys, the first thing I notice, I see a b to the 0. Remember, b to the 0 is just the number 1. So that, in essence, is just going to cancel out. I'm not going to have anything to do with it, okay? So let's use our negative 3 and let's multiply our exponents. So I'm going to multiply them with the variable parts first, okay? So now or the a to the third with another negative 3 would be a to the negative 9. 2 and 3 would be c to the negative 6. Remember, the power in my 2 is a 1. So 1 times negative 3 would be a negative 3. Okay. Now, let's flip everything because everything has negative exponents. So that's going to become a c to the positive 6, a 2 to the third, and an a to the ninth. And guys, we just did 2 to the third on the problem before. So remember, 2 to the third was 8, a to the ninth. Okay. All right. So the last part I have here in 4.2 deals with scientific notation. Scientific notation is basically a way we can write really, really big numbers or really, really small numbers. If you end up taking chemistry, you're going to see scientific notation there because sometimes the numbers are really, really big and sometimes the numbers are really, really small. Okay, you see that a lot in science classes. Excuse me. So let's take a look here. We're going to write a number in scientific notation. We're going to write it in this form right here. Okay, that number a, think about it like this, where it gives me this information. It has to be $1 or more, but it has to be less than $10, okay? So right now, I'm going to come back over here. Let me get a different color. Even though I don't see it, the decimal point really is at the end, right? What I'm going to do is I'm going to move my decimal point, and I'm going to move it so that when I end up with the number that I have is more than $1, or $1 or more, but less than 10. So if I start moving my decimal point over to the right, and if I put it between the 1 and the 5, look what number I end up with, 1.57. That is $1 or more, like $1.57, but it's less than 10. So I couldn't have put it between the 5 and the 7 because that would have given me $15.70, and I couldn't put it to the left of the 1 because that would have given me like 15 cents. So it has to be between those first two numbers, right? Okay, now the next part, we're going to multiply it by 10 times some power. The power is just telling me how many spaces did I move my decimal point. So we notice, let's count. That's 3, that's 6, 7, 8. We moved it 8 spaces. Okay. So the way we write that number in scientific notation is 1.57 times 10 to the 8th. So guys, just to give you a heads up, that number, if I were to read it as a regular number without the scientific notation, that number is 157 million. So notice 157 million. It's a big number, right? Big numbers are going to have positive exponents. So let's take a look at the next one. Same kind of setup. 78,200. That's also a big number. Again, if I don't see my decimal point, it's understood to be at the end. I'm going to put it between the first two numbers, so 7.82 times 10. All we got to do is count. Look, that's 3 spaces. One more is 4. Again, because my number is big, my exponent is going to be positive. Now look at the next two numbers here. These numbers are really, really, really small, right? 0.0000871. That's a small number. Okay? So now I'm going to move my decimal point. I want to put it between the first two numbers that are not 0. So if I move it, I'm going to put it right there. Look at the number we end up with, 8.71 times 10. Now we're going to figure out how many spaces did we move our decimal point. Guys, all we got to do is count. Look, 1, 2, 3, 4, 5. Okay, we moved it 5 spaces, but because this is a small number, we're going to write it with a negative exponent. Okay, so big numbers have positive exponents, small numbers have negative exponents. Let's take a look at the next one here. Again, I'm going to move my decimal. It should be between the 7 and the 8, right? That's more than $1, but less than 10. And if I count 1, 2, 3, we moved it 3 spaces, but because the number is small, it is a negative 3. Okay. Guys, staying with this scientific notation, okay, it's still the last topic. I got 4 more problems right here. Now all we're going to do is we're going to go backwards. Okay, we're going to go back and write them as regular numbers. So I look at the first number here, 3.02 times 10 to the 5th. The first thing I notice, hey, that's a positive exponent. That tells me that my number is going to be big, right? Same thing for that one. Okay, so we're going to take our decimal point, we're going to move it 5 spaces to the right. Okay, so look, I'm going to have 3. I want you to think about this. We're going to move it 5 spaces. Look how many numbers I already have to the right. I already have 2. That means I need to add 1, 2, 3 more zeros. And here's my number, 302,000. It's a big number, right? The decimal used to be here, 1, 2, 3, 4, 5. There we go. Okay. Let's do the same thing for the next one. I also know that that number is going to be big because, again, my exponent is positive. Remember, we're going to move it 7 spaces that way. Notice, I already have 3 numbers here. That means I need to add 4 more zeros because I have to go a total of 7. 1, 2, 3, 4. There we go. Look at that number. 81,370,000. Again, big numbers, right? Okay. So, the next two, notice my exponents are negative. Those numbers are going to be small, right? So remember, I'm going to go 4 spaces, but to the left, right? So I'm going to ask myself, okay, how many numbers do I already have to the left? I already have 1. And if I got to have a total of 4, that means I need to have 3 zeros and then my 47, right? Look, 1, 2, 3, 4. There we go, right? Same thing here. I'm only going to go 2 spaces. I already have 1 number there. I have that 5, so I need 1, 0, 5, 3, and 6. And that is section 4.2.